Remember that ionic bonds occur when a metal transfers an electron to a nonmetal. The reason why the electron is transferred is so that both atoms can achieve a full valence shell. Well, sometimes atoms will share electrons to achieve a full valence shell. These are called covalent bonds. Now, achieving a full valence shell for most atoms means getting an 8 valence electrons. Well, this is called the octet rule. Atoms will gain, lose, or share electrons in order to achieve 8 valence electrons, or a full valence shell. The only real exceptions to this are hydrogen and helium, which are in the first energy level, which only has an s orbital, so they follow what's called the duet rule. They are satisfied, if you will, with 2 valence electrons. So covalent bonds generally form between two nonmetals. So when two nonmetals bond, they form a covalent bond, and we call these substances molecules. So once again, we can use electronegativities from our periodic table to determine whether a bond is ionic or covalent. Remember that electronegativity is an atom's ability to attract electrons in a bond. So just as a visual reference, remember ionic bonding shows a transfer of electrons, while covalent bonding shows sharing of electrons. The complete valence shells for an ionic bond would occur because an electron is being given to a nonmetal, and that results in the metal and the nonmetal getting a full valence shell. Where in covalent bonding, the electrons are shared, and then both atoms achieve a full valence shell because of the sharing of electrons. So let's look at an example that should give us covalent bonding. So if we look at hydrochloric acid, HCl, let's determine the percent ionic and percent covalent character, same way we did for ionic bonds, using our fancy periodic table. We're going to look up the electronegativity, which is the upper right number on the side of the periodic table that has all the values on it. So if we look up hydrogen's electronegativity, we see it's 2.20, and chlorine's electronegativity is 3.16. Well, we want an electronegativity difference. We want to use the table at the top of that periodic table, where we need a difference in electronegativity to be able to determine the percent ionic character. Well, to get a difference in electronegativity, we got to take 3.16 minus 2.20, and we get 0.96. So if we read our table at the top of our periodic table, we can see 0.96 lies between 0.9 and 1, where the percent ionic character is between 19 and 22. So for estimating, I would say the percent ionic character of an HCl bond is about 21%. So the covalent character then would be 100 minus that, or 79%. So this bond is mostly covalent, which means the bond type would be a covalent bond. So if we're greater than 50% ionic character, we're going to call that an ionic bond. If the covalent character is greater than 50%, we're going to call that a covalent bond. There are several different types of covalent bonds. The first type is called a polar covalent bond. A polar covalent bond occurs when you have an unequal sharing of the electrons. This happens when the two atoms forming the bond have different electronegativities. The larger electronegativity, the more that atom attracts electrons in the bond. Therefore, there will be an unequal sharing with two different atoms being bonded together. That results in a polar bond. A nonpolar bond occurs when you have two of the same atom bonded together. Therefore, the electronegativity values are the same, and the electrons are shared equally. They each have an equal attraction to the electrons in the bond. Then, with covalent bonds, you can end up having multiple bonds. A single bond occurs when each atom shares one electron. That would form a single bond. When each atom shares two electrons, you would form a double bond. And if each atom shares 3 electrons, then you form what is called a triple bond.